What that is saying is that function of x is a function, f of x, is what that's telling you, equals x plus 2. One of the things that you can do, if you're using your calculator and whatnot, is that f of x kind of means the exact same thing as y equals. What you're doing here is you're going to take some value, f of 0. That means in the equation, wherever I see x, what am I going to replace it with? 0. So this is kind of what they call function notation, and it's going to give you a value. Your input is 0, your output is 2. In your calculators, it's basically doing this. It's creating XY tables. All right? It creates tables for you guys to do this. Now, this is a real easy function to introduce you guys how your table stuff works in the calculator. Have you guys ever used the table function on this calculator yet? No. All right. Let's try this. Go ahead and take your calculators out. And we're going to do a quick little tutorial on tables. Let's turn the air conditioning on. Set it like 73. Let me lower it. It's annoying. Hot. It's warmer. It's cooler in the hallways. I'm sorry. Why isn't this loading? There we go. So here's what I want you. The function we just had was what? X plus 2? All right. Go to the y equals button and press x plus 2. Where do I get an x?
Yeah. Alpha.
No! It's not how you do alpha. There's a whole button on there that says x. Where? Right next to the alpha. This button right here, this right next to the x, or next to the alpha button, next to the green button, it says x, t, theta, n.
We want y1 equals x.
Plus 2.
How do I get a t?
There's a number between 1 and 3. Oh, I thought you said 2. How do I get a 2? I'm like, it's the number.
I was like, how is there a t there?
Okay, those are your variables, x, tau, theta, and then n. They're all interchangeable. It doesn't mean, it's just showing that that's your variable button, that's all.
So if I use different programs on this calculator, if I press that button, I can make different things.
Yes, but you have to set the program for it. And I don't do any programming. I think in physics you guys do some programming with the calculators. So if you guys take physics, you'll use programming stuff out of this. But here, all you're doing is you're creating x plus 2. Now, here's the real scary button, graph. All right, now, and I was just going to ask this. If by chance you have a graph that does not look like that, if your scale is all sorts of messed up, who has scales that are, you have the picture of Mommer still, don't you?
Yeah. This graph's messed up.
All right, now, can I see yours real quick? Can you start seeing that?
Who's on Mommer's saying that?
How do you clear memory?
I'm resetting it right now.
Check this graph.
Okay, now it's back to normal. I shouldn't have laughed, but that was pretty funny. Anyway, if your graph doesn't look like that, if it's all sorts of out of whack and it's all crazy and your grid is, you don't see the regular standard XY grid, what you want to do is just reset it. Yes, sir? I'm just going to do this. We type in second plus sign.
Down.
7, 2, 2. Second plus sign 7, 1, 2.
That was a lot more complicated than there is in the second.
Second plus 7, 1, 2. You can do them in either order. It resets it. Second plus 7, 2, 2. And that restores it to the defaults. And the default settings go to the X and Y grid at 10 by 10. It goes 10 by 10, and then it automatically sets it If you're worried about trigonometry stuff, it'll reset it into radian mode as well. We don't need to worry about that right now because I'm not doing any sine, cosine, tangent. Yes, sir? Did you get it?
Yes.
Okay. Second plus sign 712, second plus sign 722. This also it clears any of the stuff that was cached in the memory bank. You know, if you had, does anybody even use the memory for like storing when you're doing multiple problems with the same thing? Clear, and you can do the M plus. I never used it in my life, so I just don't know why they still do that. But anyway, so what happens now is that it resets itself to a grid like this, 10 by 10. And that usually is the best window to see the graphs that you do. Now, in order, if you wanted to get the window to change, if you wanted to shrink it down to 5 by 5, say, or something like that, if you press the button that says window.
Which we want to do this?
No, I'm just saying, sometimes you do want to move your graph around. If you do want to move your graph around and get a different perspective on, if you know the graph is all in the second quadrant, you want to shift things around, that's where you do your shifting. You just change the scale. The only ones you have to worry about pressing and changing are the X minimum, X maximum, and the Y min, Y max. That's just telling you how high up and how low down it can go, left and right, so you can shift it into certain spots. You can create your own window, that's why they call it that. Okay? But generally speaking, it's usually set as a 10 by 10, so you don't have to worry about it. So if by chance next time someone's messing around with it, or in science a lot of times they change the graphs, they take the grid off of it to look at some of the exponential stuff, and I'm sure they do that too. You'll see how that goes. But if all else fails and you don't know what to do with your calculator, second plus 712, second plus 722, and it restores everything back to normal. Okay? I'm not sure how to reset on yours, but I think your grid is the standard 10 by 10 right off the bat as well. The buttons you press might just be a little bit different sequence to get to the graph, but you can get to the graph, right? When you're on the graph, there should be an option that says table. Was there one? So let's go back to the your y equals x plus 2. Let's retype that in. Was there an option I can type that? Now, once you get your graph, you can hit the button that says second table. And all of a sudden, it sets you up with all your possible x values, your input, and your output. So if you substitute in 0, you get 2, 1, and 3. These become your ordered pairs.
So we are at x plus 2.
Yeah.
And we do what?
Second table. So you're able to go up and down the values. You can set the table where you want the table to start. Really, it's never that big of an issue. I think the default starts the table at 0. I usually set mine to start at like -3, because that way I see a couple of negative values working towards the positive value, so I know what's happening when it's about the x-axis, the xy axis there. There's a lot of little tricks that you can do with this. The way that it's set up is standard, you're fine. So anyway, the reason why I was showing you guys how this table stuff works is that what we're going to be doing is using these functions, using these f of x style problems, and doing some direct substitutions. More often than not, you see this style problem on ACTs. F of g, composite functions, things like that, where you're taking direct substitution and you're solving. It's going to look like, bless you, it's going to look like this. You are given 4 different equations, 4 different functions that are showing up here. F of x is 7x minus 12. M of x is 1/2 x plus 4. B of x is negative x plus 5. And R of x is 2x squared plus 3x. And then they give you a list of problems. Now, I'm hoping we know our letters. We all know our ABCs, right?
Yeah.
So if I have f of 9, which equation do you think I have to use? The first one. Is that because it starts with the letter F? Exactly. And that's what it is. What this is telling us to do is that it says, look at the equation that deals with F, and anywhere I see an X in that equation, what am I going to substitute? 9. What's 7 times 9? Minus 12. And so on. Try those. All this is direct substitution. Now, if you want, you can use your calculator and set up tables by creating the y equals button and re-go through tables. Sometimes that is very beneficial, especially if you're a type of student that messes up on negatives, because it alleviates that problem. All right? But take a second, try a couple of those. And I'll explain what b of f of x is and m of 4 is, so don't do those two yet. I'll show you what that means here in a second. That's good. There you go. No problem. Yes, sir.
So, are we supposed to be doing the second row with the same first one?
Yeah, you still do those. And if you know what that means, go for it. But I'm going to re-explain it to everybody here.
Find this example from the ACT here where you see this.
Right. Now this is directly out of the ACT.
I like the triangle.
Thanks. That's directly out of the ACT.
It's a triangle thing.
I don't want you to think change in x here. And I know you want to say, oh, it's a change in x. No. All this says is take this -2 and substitute it in for x. It's function notation on crack.
That's cool.
That's all it is. It's a bad habit. And I'd lay off it as much as possible. This is just, it's just another way of seeing function notation. You do see this quite often. You will see this on ACT stuff. That's why I just want to make sure that we understand what this direct substitution goes for. So in these examples here, f of -3, -21 minus 12. Okay. B of 2. What did you guys get? 3. Good. R of -4. What? What are we getting? 22, 20, 20? Negative. Did we get something different? Remember, watch your signs. 2 times -4 quantity squared plus 3 times -4. Now, here's where I would make sure that sometimes it's not a bad idea to use the table function. I know how you guys think sometimes, and I know that sometimes you forget to put parentheses around negatives in calculators. One way to completely alleviate that from happening is, once again, just to show you, to use your y equals button. It was 2x squared plus 3x. So I hit 2x squared plus 3x. And I go right to my table, and I go looking for -4. And I got 4. The table does it for me. Crazy, isn't it? Yeah. What's that? The table button again is you hit second graph. You see how it's highlighted in, I think it's blue? And that allows you to go to that table function. Now, like I said, that table function is awesome if you have got a lot of substitutions to do, especially like if you are one of those types of people that tends to make mistakes with negatives. Okay? Just wanted to introduce you to that today. Also, M of car. What do you do when you have M of car?
Substitute car for
Okay? For M or
X.
for X? So you wind up with 1/2 car plus 4. And can you do anything with that?
R plus 2. Oh wait, no.
Can I do anything with that? No, I'm done. All this means is you take what's in, you take whatever is in here, and you substitute it for X. If you can simplify, you simplify. If you can't, you leave it. It's kind of like a goofy example, but that's all it means. All right? That's all it means. You can't do anything with it. You're not going to cut a car in half. It's not cut. Car in half is cut.
That was so funny.
What was the joke?
He didn't pronounce the entire word.
Car.
It's just, you see in half of it.
Wait, what?
How can you have half of a what?
Oh,
Careful.
I get it.
You have to be older. You'll learn when you're older.
All right. Now, when you get down to the ones that have the double substitution, when you think about order of operations tells you to work the innermost parentheses and work your way out. Remember those from Please Excuse My Dear Aunt Sally? Means the exact same thing when you're looking at the function stuff. What you do here is you take X and you substitute into F. Whatever you get for that, you substitute into B. Okay? So here in F, I'm taking the X. Maybe I should have done this as B of F of 3. I'll change it to a number. I didn't realize I had typed in a value here. What that tells me to do is go to the innermost equation, the F equation, and substitute in 3. So once again, 7 times 3 is 21. 21 minus 12 is 9. Well, we're not doing any electrical work, but we would substitute. And that's exactly what you would do. You solve for this innermost part first, and we got, does everybody agree with me it was 9? 21 minus 12?
It's negative.
It was just positive 3, so it would be,
Oh, positive.
yeah. So then I got 9, so then it becomes B of 9, and I go to the B equation with that. And then I get -4 for full answer then. So this is just another way of writing like a Please Excuse My Dear Aunt Sally problem. Solve the first part, get an answer, and substitute the second part. It's a composite. Okay? You're putting two things together. Same thing with the M of 4. I figure out what the M of 4 is. 6. Then I take that 6 and I go back into the M equation again. And I get 7. Yes, sir.
But like, okay, so let's say F is -3.
Uh-huh.
Why are we just substituting that into the 7x minus 12? Why don't we write it -3 equals 7x times -3 equals 12?
What you're doing, I know what you're saying. You're trying to. You don't put the -3 as the output. The -3 is the input. This is your x value. instead of, you're trying to write it like this. Is that what you're saying?
Well, I'm saying is since there's two X's there,
Mm-hmm.
then why are they both substituted?
Oh, okay. In the perfect world, what it would look like is f of -3 equals 7 times -3 minus 12. In the perfect world, that's what it should show. I got lazy and just wrote 7 times -3 minus 12. Does that make more sense?
Yeah.
In the end, is your final answer like the combination of the first?
Yes.
equation?
Yeah, you're working your way out. So this part here gave us 6.
Yeah.
So that means we now have m of 6, and then that gives us
So
7.
your final thing is
Yeah.
7.
Mhm.
Okay.
Yep. You're just building yourself out of it. All right.
Wait,
Now,
so would we write those separate, or we would write m in parentheses m
Yeah.
equals 7, or would we write m equals 6 and then equals 7?
either one is fine because you have to get to here to get to here. And that's fine. Now, what we're doing today doesn't have a lot of this combination of stuff. I just wanted to show you guys how it looks and what you're going to see later when we get to this kind of stuff, when you guys do take the ACT and all that.
So basically, the triangle thing is just the parentheses.
They try to trick you. I've seen triangles, I've seen rectangles. They're just, I want you to see if they do a shape thing like this. When you see that thrown in there, that just means substitute, okay? I don't know if it was on last year's, but it's always in the study guides, it's always in the practice stuff. You will see something like that. So, just wanted to introduce you to that today. Now, where does this all get us then? Well, where this is getting us to, yes, sir?
How did you get B of 9 equals negative?
B of 9?
Down at the bottom.
Okay. What I did here was, when I typed this in here, I didn't realize I put an X. I wanted to do a value, so I figured it on 3. So I did f of 3, that's 21 and 12. 21 minus 12 was 9.
Oh, yeah, okay, you have to go to that one first.
Correct.
Okay.
Remember, work on your, think of like it's an order of operations problem without all the stuff being shown. Work on your inside and you're working your way up. Does that make more sense? Perfect. So like I said, where is this getting us? It is getting us into what are called piecewise functions. Basically what this is nothing more than two equations that are domain specific. Now, do you guys remember what the word domain meant again? Something, good. Narrow it down. Don't say something that deals with math. You guys remember what the domain meant? There's domain and range. Which one's which? What comes first in the alphabet, domain or range? If you were to look up in a dictionary, domain or range, what comes first?
That's not the alphabet, that's a dictionary.
Alphabetically speaking, which one comes first? Domain or range?
Oh my gosh. I'm gonna
What,
go with what is domain.
what comes first in the alphabet? Is that okay for a statement? X or Y? Everybody always hesitates because they're Q, R, S, T, U, V, W. Yeah. So what corresponds with domain then, do you think? X. And then Y corresponds to your range. So what happens here is that this graph will only be graphed for a specific domain. A domain, oops, of numbers between -2 and 6. And if the numbers work between -2 and 6, let's say they're between -8 and -4, that domain would be graphed with that, -x. A real easy example of where this is shown. You guys ever heard of overtime?
Yes.
It's generally time and a half, right?
I like overtime.
Is that right? Time and a half? So if you're making $10 an hour, what's time and a half? 15. Good. Now, at $10 an hour, that's usually for the first 40 hours. After that, you get time and a half, whatever hours are left. So what happens here is your domain for working overtime between 0 and 40 hours, you get 10 times X. That's your $10 an hour. When it's above 40, you get 15 times X. That's how you calculate, that's a piecewise function. It's domain specific. Your rate at what you're making money increases.
And so what would it look like for them? So you're putting it into the, like, the inequality.
I'm getting there. Okay, I'm getting there. So, like I said, a very, very basic idea of what a piecewise function will look like is just thinking about overtime. So what we're going to do today, though, is just kind of work with the first starts of it. We're going to work with the first starts of it, which means we're going to be given just a function, the f of x, that has two separate parts. Now, if I'm looking for f of 0, which equation does it relate to? The 2x plus 1 or the negative x? 2x plus 1. So that means at 0, I come over to my equations and I figure out which one does it go into. Well, f of 0 is going to equal 2 times 0 plus 1, which is 1.
Why do we put it into the top one?
Because this is my x value, that is my domain. These are domain specific. Which one does the 0 fall into? It falls into the first equations.
Oh, all right.
Okay, so it falls in the first equation. So that's why I use this. I use the 2x plus 1. Okay. At f of negative 7. F of negative 7. Does that go into the top one or the bottom one? It goes into the bottom one. So at f of negative 7, it becomes negative of negative 7, which is 7. F of negative 3. Does that fall into one of our domains? No. So what happens when something doesn't work?
Do it.
Don't do it, skip it. Ask about it tomorrow. In this case, since it's not going to work, can I just say, you know what that means? It's like an empty set. No, not going to work. You could probably use undefined. Undefined would be okay with me too, because it's not a definable domain. Okay. You guys heard the term undefined before? So you can use undefined or the little circle with a slash through it. It's basically the exact same thing. So like I said, since these two equations are domain specific, and that negative 3 does not fall within any of the domains that I'm looking for, it's undefined. Okay. F of 4. Which one is that going to fall in?
The top one.
The top one again.
Okay, look at your equation right here.
It falls in the top one.
Give your x
So f of 4, I get 8 plus 1, and I get 9. Okay. Questions? Let me give you a couple to try. I wrote these out for you so you don't have to write them down because it's quicker.
So are all these problems going to have that, like, the domain thing?
Yeah. They're domain specific. Now, we got a couple minutes. We should be able to get through a couple of these together. I even hole punched it in case you guys needed that. Look at me. Let's look at the first part, the top 12. Now, to be honest with you, since we only have 3 minutes, here's what I want you to do then tonight. For the homework tonight, do them all. All 24, please. Okay? Now, what we will do tomorrow